Let's look. We're first going to do a review of how we did the problems yesterday. And then I'm going to show you the standard algorithm-y way that some of you in here are already doing without being shown. But yesterday we used the fraction pieces. You had the polypad and you used the fraction bars on the computer to build the problems and solve the problems. So if we look at this problem, we always start with 1 because that's going to tell us if we're less than or greater than 1. Our problem is 1/6 plus 3/4. Knox, is my problem going to be less than or greater than 1? Less, good. Because it doesn't go out past 1. Yes, ma'am. Don't tell me the answer yet. So now, you need to watch because you weren't here. Now what we do is we want to find equal pieces that would fit under here exactly. They all have to be the same piece. So Knox, what piece do you think we should use? All right, so we're going to try 12ths. And we're going to see if we can get 12ths to line up exactly, precisely underneath this so that there is no overlap, no space.
Right there.
What? And it looks like 12ths will work. So my answer would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 12ths. So my answer would be 11 12ths. Okay, everybody see how we did this? We did it, several of them yesterday. Now, we're going to use the standard mathematical way this time to do the same problem. 1/6 plus 3/4. 1/6 plus 3/4. But as you know, we can't add these fractions like they're written. Why can't we add them like they're written? Anybody? Just say it. They have different denominators. Now, most of the denominators you're going to see in 5th grade, you could probably do in your mind. But let's try. I'm going to show you how to find the common denominator. I'm going to take both my denominators, which are 6 and 4. 6 and 4. And I'm going to write the multiples of my denominator. So 6, 12, 18. And I don't have to keep going because you could go on forever. 4, 8, 12. The first one they have in common is my least common denominator. So 12 is the first one we have in common. We found that when we did it with the fraction pieces. So we need to make equivalent fractions where they both have a denominator of 12. Now, one of the games I was having you play on the interweb, we talked about equivalent fractions. When we made the pieces yesterday, we talked about equivalent fractions. On Dreambox, you have problems like this where you have to find equivalent fractions. A lot of times they're in a chart, though, and you have to... So then, once I found my equivalent fraction, I got to ask myself, what did I multiply by 6 to get 12? 2. And I could see that because I know 1/6 equals 2/12. So if 1/6 equals 2/12, I'm going to have to put the 2 there because 1/6 equals 2/12. Then I ask myself, what did I multiply by 4 to get 12? And myself says 3. And that gives me 9/12. So 3/4, and if we already have it up here, 3/4 does equal 9/12. 1/6 does equal 2/12. Now I can add them together now because I have the same denominator. So what is 2/12 plus 9/12? 11/12. So we've got the answer, the same answer as when we used our fraction pieces. And we used them a little bit to find the equivalent fractions. So now we have 5/6 and 1/2. 5/6 and 1/2. I'm going to start by comparing it to 1. No, I won't, because I want it to annoy you. It is annoying to leave it upside down, isn't it? We have 5/6. Wait, no, I got 10 numbers. 5/6 plus 1/2. 5/6 plus 1/2. Now, if we did breaking it up, we could do 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 if we decomposed it, plus 1/2. Now we need to find a common denominator, a common fraction that would fit exactly under there. So now we have to do a little bit of thinking. We know we have 5/6. Are there any number of sixths that would fit in this space right here? I know my answer is going to be 1 and, because it's greater than 1. 1 and, Destry? 3, 6. 1 and 1, 2. Oh, not 1 and 3, 6.
Oh, I was doing it from the bottom.
Oh, 1 and 2/6.
That's 1.
So we have 1 and 2/6. Is there a way I could, what they say, simplify 2/6 and make it with fewer pieces? Kaylee?
1/3.
1/3.
Since I got the answer right, can you please flip the 1?
So 2/6 does equal 1/3. So as we get moving on with this, I would expect to see them written in what they call the simplest terms, the simplified, reduced. Please don't drive me insane. Now, if we wanted to use the standard algorithm, we'd have 5/6 plus 1/2. I would take my count them, 2 denominators, which are 6 and 2, and I'm going to list my multiples: 6, 12, 18, 2, 4, 6. Oh, look, they have 6 in common, so I'm going to have to change them so they both have a denominator of 6. Well, 5/6 is already 5/6. It's 6. And 1/2 is going to equal 3/6. 1/2 equals 3/6. Oh, let me fix this. 1/2 equals 3/6.
Literally?
Yeah.
That is an improper fraction.
So, what I did to get from a denominator of 2 to a denominator of 6 is I have to multiply by 3. And 1 times 3 is 3. Now 5/6 plus 3/6 is 8/6. Which is what? Improper. So if I decomposed it, I could do 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. That's 1, 2, 3, 4, 5. Plus 1/6. Now I know it's greater than 1. So what fraction with a denominator of 6 equals 1? Okay, if I have a denominator of 6, how many sixths equal 1? 6 6. So I could also decompose it as 6/6 plus 1/6 plus 1/6. 6/6 plus 1/6 plus 1/6. Yes, ma'am. Yeah, I could make this 4/3 as well. All right, well, 6/6 plus 1/6 plus 2/6 is 1 and 2/6. And we already said 1 and 2 6 simplifies down to 1 and 1/3. 1 and 2 6 simplifies down to 1 and 1/3. Questions? Yes, ma'am.
Can you flip the 1 over there?
Oh my gosh.